Hi everyone, in this video I'm going to show you how you can make alterations to your model without having to start your model from scratch. What we discussed in the previous video is how to add a stiffener in the middle of your beam for the application of the load. So the way I'm going to apply the stiffener is by connecting this bottom flange and the top flange with a plate that will have the following shape. So I'm going to do something that connects our elements like this and then like that. But since we're not modeling the thickness, we're modeling this as shell elements, this is going to end up being just a plate with this area. So that's the first thing I'm going to try to model in Abaqus. So to do that, I'm going to go here on parts and I'm going to start a new part, and this will be a shell and going to be planar, and it's going to be called part 2. That's fine with me. And what I'm going to do, I'm going to draw a section that resembles the one I need, but it doesn't need to be very accurate because we're going to change the variables in the next file. So I'm going to go 5 squares up, then I can go there, then 1 down, and then 1 here. As long as this is symmetric, this should be fine. Another thing that is important, I started at 0, 0 because I know this is where I started my model. So I'm happy with this. I'm going to press done, and now I have my part. But most importantly, I have a model that told me how I can create this part. So what I can do now, I can go on File and save this random model. We can do it here on folder number 1. That's fine. Let's call this plate. We're not going to use this model for anything, so it doesn't really matter. So this is saved. So if I go now into my folder number 1, I should have here my plate and my plate.jnl. So if I want, I can change this to a Python. So maybe we can do that, although not necessary at this moment, but just to keep it consistent. We can change this to plate.py. That's fine. And what you will see when we open with Notepad++ is this has the same exact script as the one we developed here, obviously without the variables because it's being substituted by numbers. And here at the bottom, after the job, so if I go here and I give a little bit of space after the job, that's the part where this script ends. So after the job, there is this piece of code. And this piece of code, if you see, it is a constraint sketch between 0, 0 and then this point, horizontal, line, so it does exactly what I just did. So what I'm going to do, I'm going to copy this, and you'll see here in line 147, it calls it part 2, so that's exactly what I need. So I'm going to go into my original model, and after the creation of part number 1, which should end here, I'm going to paste this piece of code, and I'm going to add a comment so I don't forget. This creates the stiffener geometry. Okay, and now what you can see is because this came from Abaqus, there's no parameters just yet, so we need to do that one more time. So we know we started at 0, 0, then we went to the right. So we can kind of follow the same as we've done here. So we went to the right, so that's bottom flange width divided by 2. So here we go. Then we moved up, so from this point, we moved to the top flange width, and then the height will be the height of the model, which I forgot the name of the variable. Should be this one, model height. So I'm going to paste it here in the 25. So the model height is the 25. I can be sure that that's what I need to do here. Okay, so this is looking okay. So the next one is from top flange width divided by 2 model height to minus top flange width model height. So this is looking good. Then we go from minus to, so not all the 25s are the same. So maybe we could have changed this, but it's not too bad. Then we go down to 0, and then the final point will be minus back to 0, 0. So this is looking fine, and this is called part number 2, so I'm very happy with this. So if I save, I can go now into my original script. And now, as you can see, when we go into parts, we have part number 1, which is the beam, and we have part number 2, which is the stiffener with the same geometry. So what's our next objective? We are going to use the same material for the stiffener. I'm happy with that. And now we need to create a thickness for the stiffener. So we can create a new variable here called stiffener thickness, and I'm going to be this equal to 11. And now, in this specific case, we really don't need to rerun the code because we know that this piece of code creates a section. So let's just copy it and try to figure out what we need to change. So material 1 is fine. We're going to call it section 4. And everything else is fine. It's just the thickness needs to change from bottom flange thickness to stiffener thickness. Okay, this is looking good. Okay, now we need to assign the sections to the plates. So this might be easy to do here, but it might also not work. So what I'm going to do the assignment here, and then because it's recording, I can go to the JNL and see how to do. So if I run it one more time, I should now have 4 sections. So here they are. I have section number 4 with a thickness of 11. So what I'm going to do is do the assignment. So I go here, section assignment manager, and create in part number 2. Press here, create, press done, and then assign section number 4. So this is looking fine. And then I can close, and I'm going to save my model. I can save it on top of this, I think. Let's see if this works. Okay, that worked. So now if I go to the JNL, and we're going to try to find, here it is. So after the job, this is the part that does the assignment. So I'm just going to copy this and paste it here in the model PY. So this should do the assignment. So now it's top flange, web, bottom flange, and stiffener. So this is looking good. Now we go into the assembly. So now obviously I want to start the assembly with part 1 and part 2. So what I'm going to do now is, because this will start the entire model, what I'm going to do from this line all the way down. So I put my cursor here in 165 and I go all the way down, and I'm going to do Control K to comment the entire model. So when I save and I run again, the assembly won't be created. So now I'm going to go here and run. And now as you can see, the assembly is not there yet. So what I'm going to do is start the assembly, create the instance, and bring the 2 parts together. Okay? And now one thing that you can see straight away is the stiffener is not in the place that I want, because it's in the assembly that we need to move it into the place that we need. So if I want to translate the instance, I can press here, translate instance, select the thing I want to translate, press done. And now the vector first is the starting point. So we can start with 0, 0, 0, and then we want the end to be 0, 0, let's say 3000. It doesn't matter because I'm going to change this number in the code. And now it moved it over there. I'm going to say okay, that I'm happy with this position and that we're done. So now if I go and I save my file, I can save it again in this folder number 1. What is going to be interesting is in Notepad++, this is going to tell me that this was changed. So it's going to update it automatically. So I can find exactly where I changed the model. So you can see here, there is this section assignment, which was where I stopped. And then here we have the assembly, the instance, and then the translation. So I'm just going to copy this. And now I know that the assembly will be first. So now it's assembling part 1 and part 2. And now I'm just going to have a comment here to say this translates the stiffener to mid-span. And now the only thing I need to do is to take this 3000 and make it equal to span divided by 2. And this should always work no matter what the span is. So one of the things I forgot to do in this model is when you add a second part, you need to merge the 2 instances, otherwise they won't be connected in the model. So what I'm going to do now is select the 2 instances, and here in assembly, go into merge cut instance. So I'm just going to merge this into part 3. I'm going to merge the geometry, suppress the original instances, and remove the boundaries. And here I'll select the instances, press done, and this should create now part 3.1 that has both of them acting together. So again, I'm going to save this here in my plate, and I'm going to go here onto my JNL and find that here at the bottom, after the translation, I have here the merging of the two. Okay, so it's looking good. Then we can move on into the step. I don't think this is going to change, so this stays the same. Now this part, to create the point at midspan, we needed to make the mesh independent, and then we needed to find the node by partitioning the line. But now that we merge them, most likely that node will already be possible to click on. So here it is. So if I go to loads, and if I apply the load there, so I'm going to go into create, this doesn't have the step, so let's run it one more time. Maybe commenting this and save. So if I run one more time, I should be able to now apply the load in step 1, concentrated force, and I think it's in CW2 minus 1000, but this part doesn't really matter. And here it is. So this was, I was able to click on it and apply the point there. So now if I save, I should be able to get the code that does it. And again, here after the step, here we are, concentrated force. So I can get rid of the make independent part, and I can get rid of the partition. And now this part that applies the load, I can just paste this instead. Now there's an interesting thing going on here. There's a very, very important part on Abaqus, which is very tricky to explain as well, which is about this get sequence from mask. So what I'm going to do, I'm going to comment this one more time, and I'm going to get a piece of code that is very, very important, which is this one here. And I'm going to paste this into the top of the model. So most of the times that I work in Abaqus, I have this at the top. I was just waiting for an opportunity to show you what this does. So this changes the journal options to replay the geometry to coordinate and recover the geometry to coordinate. So this might not mean anything, but I'll show you what this means. So I'm going to save the model, and it's commented here in the load. So what I'm going to do, I'm going to run it one more time. And I'm going to apply the load again. So now if I go here on loads and I try to apply it exactly like I did before, I press the node, minus 1000. This is looking good. Press OK. And now I'm going to save. And I want you to see the difference between the two codes. So fantastic. I can go here to concentrated force. I can copy. And I can paste. So let's look into these codes, these two codes side by side. So if you see, the load is the same, the step is the same, everything is the same, except this definition of the region. So the region, before I added that piece of code, found a vertex and then got this get sequence from mask, and has this very cryptic piece of code inside. While if you use the recover geometry equals coordinate in the beginning, what you're going to see is instead of the get sequence from mask, you find the vertex at a specific coordinate. So this here is a lot more powerful than this, because the get sequence from mask, no one really knows what it does and what it means. Sometimes it works, sometimes it doesn't. If you're careful, it can work. So I can show you an example where this is working so far, which is here when we assigned the sections to the plates. And that's because we are working with very simple models and we are working within the parts. So sometimes this can work, but I recommend take this piece of code and I would run it in your Abaqus before you do your step 1. And this allows that every get sequence from mask transforms into a find at function, which is much more powerful. Now, I don't think for a simple model like this, it's very important, but if you're trying to replicate your models and then maybe send it to other people, this piece of code is very important. So one thing that I'm going to do, I'm going to get this load of 5,000 and I'm going to paste it here. And now also I'm going to remove this piece of code with a get sequence from mask. And now what I'm going to do is change this to span divided by 2. And this should be the model height. So basically what this piece of code does, it's exactly like you taking your mouse and going and clicking the coordinates that is specified here in the find at function. So this is looking good. Now boundary conditions, we're gonna update them. And one thing that is interesting is let's see what the get sequence from mask does when we're not careful and we start making alterations. By the way, this works very well if we don't make any changes. That's why our initial model is working. But because we're making changes, this get sequence for mask might not work. And the proof for this is if I go and I see where the boundary conditions are, they're not there yet. So are they uncommented? Yes. So I'm just going to run it one more time. Okay, so it's telling me I have an error in line 202, which is associated with the get sequence for mask. So straight away, this is giving me errors because I changed the way this model is set up. Because now that I have this plate here in the middle, all these plates are divided in different ways. The edges are different. So the numbers and the names of these edges for Abaqus changed. So therefore, this get sequence for mask is not working anymore. So let's redo the boundary conditions. So what I wanted to do was in loads, boundary condition manager, create displacement rotation. Now we're going to select these two lines, press done, and then have U1, U2, and U3. And then on the other side, we're going to rotate this as well. Now we're going to do another one. Select this displacement rotation, select these two lines, press done, and now we put just U1 and U2. Okay, so this is looking good. And now I'm just going to save, plate. Yes, that's fine. And now back into my Notepad++. And after my force, so I have here the error, which is interesting. And now here are my two boundary conditions. So I'm just going to copy, place them here, just confirm that they are exactly like the other ones are. So this one was 0, 0, 0 and unset. And then this one's is 0, 0 and unset. So the only thing I need to do is this get sequence from mask replace with this find at. So I know that one of them will be in the position that is at the end, which is the span. Now this one in Z is 0, that's fine. Then in Y they're all 0, which is also fine. And now here I need something that allows me to click that line over there. So if I know that's 0, 0, and I know that is the bottom flange width divided by 2, I can, for example, replace this with bottom flange width divided by 4. So I can go and take this and replace this minus 25 with that, and this with that, and this minus 25 with that, and this with that. All of them divided by 4. And I divided by 4, but I could divide by any other number bigger than 2, because what we want is for them to select the lines, one to the left of 0 and another one to the right of 0, but no bigger than bottom flange divided by 2. So what I'm trying to say is any coordinate between 0, 0 and 0 bottom flange divided by 2, so any point here in the middle would be fine. Okay, so I'm happy with this. I'm going to delete this get sequence from mask. Now we have the meshing of the assembly. So this part is not going to work because it's meshing a part that is now inactive. So this actually should be simple to do because I know the name of the part that I want to mesh. So if I go to assembly, my part is now part 3.1. So this should be straightforward, just doing this and replacing the 1 with a 3. Mesh size is fine. And this creates the job. So let's remove all these comments, save, and see if this runs with any error or not. Okay, this is looking fine. Let's test the boundary conditions. They're there. The other side, yeah, it's also there. The load is in the right place. Perfect. The stiffener is there. So now we're ready to run. So I'm just going to uncomment this and I'm going to let it run one more time. So as you can see, my model is not working properly. And I figured out that that's because of the mesh. So when I changed that to 3.1, that didn't work. Let's do the mesh properly because that's the easiest way. So don't try to change your code like this, especially if you're a beginner. Sometimes you can try it just to see if you know how to do it, but sometimes it backfires as it just did. So let's just go here and mesh the parts. So we can mesh the part number 3 straight away and mesh. This is fine. So now we can save, and we can save this again with the nameplate, not important. So now when you go here to test Python, open our plate JNL, and at the bottom we should have the code to mesh this correctly. So these are the messages from the errors, and this is the part that we need. So I'm just going to copy this, paste it here. So instead of this part, we're just going to have this. So we replace this size of 230 with mesh size, and then we generate the mesh. So this is fine. Now let's save. Hopefully this will run now. Okay, so the model just finished running. Let's just check if everything is okay. Check the results. So okay, so now it's all working fantastically. So this is going to be my final piece of code before the post-processing, which I'll show you in the next video. This is it. So today we learned how to edit the model. You saw that it's a complicated process and it requires a little bit of knowledge. But again, it saves you the time of having to do everything from scratch. So hopefully now you know how to do both, how to start from scratch a model and how to make small alterations in it. So then you can decide what you want your model to do before you move into post-processing and before you create the master file to run this as many times as you need. So thank you for watching and have a nice day.